We will continue to talk about security method in Java OOAD programming. We know that if a method is sensitive, then we should not allow the class to be extended or the method to be overridden. To secure such sensitive method, we should define method or the class as final. In this talk, we will discuss some of the OOAD security issues for Java methods, for example, parameters, which could be dangerous and need to check, validate, normalize, and sanitize before processing. In this example, the set date this set state method needs to check whether the parameter is raw or not. If the parameter is raw, then we need to handle such a situation. The next step is to create a defensive copy if the parameter object is mutable. In the use state method, we also need to evaluate whether the status of the object is null or not. That is a defensive programming. To emphasize one more time, if the method itself is sensitive, then we should not allow it to be overridden. Let's take a look at this example. Here we define a read sensitive file method and then bypass the control by the security manager. To control such vulnerability, the read sensitive file method should be defined as either private or final public, so it cannot be extended and change the logic to bypass the security manager check. Another security issue is the potential increase of the accessibility due to method overridden to an inappropriate level. So how to define this type of dangerous public method overridden? One way is to define the primed method as a final method. Once you define its final method, then child class cannot overridden. Yet the other issue is to deal with mutable objects. Either we can make it has no accessibility to those objects so you cannot change, or you can enforce a defensive copy whenever potential change might be made. In this example, an employee object is used as a mapping key for a map connection. The evaluation of the key value is to compare the employee name of an employee object. There are two issues here. One issue is that the employee object itself is mutable, and employee name can also be changed. Another issue is that the equal method can be overridden and logics can be changed. How to make such method secure? One approach is that instead of using the object as the key, we can just use a primitive data type variable such as integer variable and mark it as a final variable, like here, the employee ID. This is probably the best way. If we have to use the object as the key for a mapping connection, then one primitive data type member variable of that object should be defined for that object. Mark such member as final. In this case, we have to use employee ID object as the key, but we compare by using its member, integer member, primitive data type integer member, employee ID, which is also defined as final. Or we can simply don't provide any accessible method to change such a member variable if it is not marked as final. In this way, such a member variable will not be able to modify it once it is initialized. Now we will discuss the principles for comparing objects such as symmetric, transitive, ensure, etc. The transitive principle means if x compared to y, if it is greater than 0 and y compared to z is greater than 0, then x compared to z should also be greater than 0. So that's called transitive. To ensure principle means that if x compared to y is 0, then the sign of x compared to z should be equal to sign y compared to z. So symmetrically means if we have the result of x compared to y equal to sin y compared to x, with this negative. Okay, in this example, shows the transitive principle. We have rock, paper, and scissors. This program fails the transitive principle because the relationship among rock, paper, and scissors will have a circle. Okay, so that's pretty much about the secure method, and the rest of the principles, comparing principle, you guys can read the slides.